All right, these rational equations are just a little bit more involved because the denominators aren't simply monomials like x or 3 times x. We've got x plus 5, x minus 5, and x squared minus 25. So we need to multiply by each of these things in order to cancel them out and get rid of our fractions. Now, if you just multiply by all three of them, x plus 5, x minus 5, x squared minus 25, you're going to have a real mess. What you want to do first is factor any of them that can be factored. If you remember difference of squares, x squared minus 25 is x minus 5 times x plus 5. Well, that's obviously the same as these two. So in order to cancel out all of the fractions here, all I have to multiply by is x minus 5 and x plus 5. And we're going to distribute that through. When we multiply this times 2 over x plus 5, we have a times x plus 5 and a divided by x plus 5. Those are going to cancel each other out, and we're going to be left with the 2 and the x minus 5. When we multiply this times the middle one, the x minus 5s will cancel. We have multiplied by here and divided by there, and we'll be left with the 1 and the x plus 5. And when we multiply this times these, well, we're multiplying by both and dividing by both. They'll all cancel, and we'll be left with just the 16. Can you pay attention to how nice and easy that was? If you start getting long, ugly, complicated things when you're doing this, you're not doing it right. All the ugly stuff, the fractions should cancel out, and we should be left with something that is only going to require a little distributive property here. So 2x minus 10 plus x plus 5 equals 16. I'm starting to feel like I did something wrong here. I don't think so. Okay, so 2x plus x is 3x. Minus 5 equals 16. Add 5 to both sides. We get 21 over here. 3x is equal to 21. Divide both sides by 3. We get x is equal to 7. Done. Okay, that's all there is to it. Unless there's a little more, which there will be here. Want to follow the same rule, though. We're going to multiply by x and x plus 2 to get rid of these guys. But this one you want to recognize is x times x plus 2. We can pull a factor out of there and simplify that a little bit. And then when we multiply, we're going to multiply by x times x plus 2. When we multiply here, the x plus 2's cancel, and we're left with 3x times x. So that's 3x squared. When we multiply here, the x's will cancel, and we'll be left with plus the 6 and the x plus 2. And when we multiply here, of course, both of them will cancel, and we'll be left with 12. Feels very much like that one, like the previous one, but we ended up with a quadratic instead of a linear here. So that's going to make a difference in how we finish solving this. Subtract 12 from both sides, and we get 3x squared plus 6x equals 0. And hopefully you remember from solving quadratic equations that when we have no constant term in our equation, this becomes very easy to factor. We can factor out a 3, and we can also factor out an x, and that'll leave us with x plus 2. Set each factor equal to 0 and solve, and that'll give us x is equal to 0. Or if we set this equal to 0 and subtract 2 from both sides, we'll get negative 2. All right, so we get, when we have a linear equation like we had in the first one, we get a single answer. When we have a quadratic equation like in the second, we get 2 answers, sometimes 1 answer, sometimes no answers, but typically 2. The thing we need to be careful of with rational equations is sometimes we get what's called extraneous solutions or extra solutions. Even though we didn't do anything wrong, we'll get numbers that aren't actually solutions to the equation. So we need to check them. And the only thing we need to check is if we put this number back into our original equation, does it cause division by 0? Does it make the bottom of any of those fractions equal to 0? And here, if we put a 0 in there, we have 6 over 0. So that isn't a real root. We can't put that in the equation. So it's gone. How about negative 2? If we put negative 2 in here, we get 6 over negative 2, which is fine. But negative 2 plus 2 is 0. So this will give us negative 6 over 0. We can't have that. This one's not a root either. So our real solution here is no solution. Now, sometimes when you solve equations like this, sometimes both of these will work. Sometimes one of them will work and the other one won't. And sometimes both of them won't work, but you need to check them. I'm going to partially do a couple more here, just to give you a heads up about what you're going to run into in my math lab. But I'm just going to get rid of the fractions, or not even that actually. I'm just going to discuss how to get rid of the fractions, and then you'll be left with a linear equation, and you can take it from there, no doubt. So we've got 5x plus 20 in the bottom here, x squared minus 16 in the bottom there, and x minus 4 there. If we factor this guy, we can take out a 5, and we're left with x plus 4. If we factor this guy, we've got x minus 4 times x plus 4. So what we need to multiply by to cancel out everything is 5 and x plus 4. And the x plus 4 will take care of that, but we also need the x minus 4, which will take care of the rest of it. Right? And when we distribute that, here the 5 and the x plus 4 will cancel. We'll be left with the 1 and the x minus 4. Here, so just x minus 4. Minus, when we multiply here, the x plus 4, x minus 4 will both cancel, and we'll be left with 1 times 5, also minus 5. And here, only the x minus 4 will cancel, so we'll be left with 3 times 5, which is 15, times x plus 4. Okay, and that's a linear equation. You shouldn't have any problem with that. Similarly here, this is 5 times x plus 1. This is x plus 1 times x minus 1. So what we would need to multiply by would be the 5, the x plus 1, and the x minus 1. And it would work very similarly to the previous one, but I don't want to take any more of your time in this video. It's already long enough. Moving on.